Hey guys, welcome to your first set of video notes. So go ahead and get out a piece of paper, and we're going to be looking at solving absolute value equations and inequalities. The 1-6 means it is in your textbook. If I ever get them, I will get you a textbook and then you can use it as a reference. So this is just a quick review of absolute value equations. You don't have to write this down, but absolute value is denoted by your absolute value bars, which are your straight bars, and it represents the distance a number is from 0. So it's always going to be a positive value, and that basically means that there is two different numbers that create the same absolute value, the positive of that number and the negative or the opposite of that number. So like you see here, positive 8 and negative 8 both have a distance of 8 from 0 on a number line. Okay, so we're going to jump right into looking at your steps for solving absolute value equations, and I would definitely write these down. So step 1 is to isolate the absolute value bars, and that basically means you're just going to get them by themselves the same way you solve equations for variables. Treat the absolute value like it's your variable. Step 2 is to set up two equations from here. So the way we're going to set up the two equations, the first one's easy. Just drop the absolute value bars and solve the equation as is. The second equation requires you to drop the bars and then to change the sign on the opposite side of your equation, and then you solve it. So basically, if it's positive, you make the number negative. If it was negative, you make it positive. And then step 3, and this is really important with these, is to always check your solutions. I know in the past with regular equations people don't, but with these you have to, because there are times where one of your solutions might not work, and if you don't check it, you're not going to know, and that will make a difference in your correct answer or not. So we're going to take a look at a couple examples. I want you to just see it first, and then you can write a couple of them down in your notes. If you want to write these down as well, that's fine, but I'm trying to avoid how much you guys have to write down. Okay, so for this equation, you're going to want to isolate the absolute value bars first. So we have to get rid of that 6 times the absolute value bars. So we're going to go ahead and divide by 6 on both sides, which is going to give us 5x plus 2 equals 52. And now we're ready to set up our two equations from here and solve. So our two equations, one is when you just drop the absolute value bars and write it as is. The second equation, you're going to change the sign on the other side. So 52 becomes negative 52. And now we can solve these. So subtract 2 and divide by 5 is going to give you 10. Over here, subtract 2 and divide by 5, you're going to get negative 10.8. The last thing is doing your checks for these to make sure they work. So if we plug in 10, we're going to go ahead and get 312 equals 312, which is good. And if we plug in our negative 10.8, we're going to get our same thing. So both of these solutions are good to go. Remember to do the checks because sometimes a solution does not work. Okay, next thing, same, you're going to isolate the absolute value bar. So in this case, we have to get rid of the times 3 and the minus 7. So we're going to go ahead and add 7 first and then divide by 3. And that's going to end up giving us the absolute value of x plus 2 equals 7. Then we're going to go ahead and set up our two equations. So drop the absolute value bars, and then one side stays as is, the other side gets the negative. Solve each side, we get 5 and negative 9, and then plug those in and do your checks. And both solutions do work here, so both of those would be your answers to this equation. Okay, so if you didn't write any down yet, you can write the next few down in your notes to have some examples to look at. So we've got the absolute value of 3x minus 2 equals 19. So first of all, again, we're going to go ahead and isolate the absolute value. It's done. So we're going to drop the bars and write our two different equations. And then we're going to go ahead and solve. So add 2, divide by 3 on both sides. And we should end up with x equals 7 or x equals negative 17 thirds. So you're going to go ahead and do your checks and make sure you get 19 for both of these. And if you do, then they become your solutions. And naturally you would do this yourself. If you did not do that, I will just let you know they did both work, but in the future you're going to want to definitely check. Okay, so in the second example, we're going to go ahead and isolate the absolute value bars. So you're going to subtract 8 from both sides, and that's going to give you this. And then you're going to go ahead and create your two equations from here, one with a positive 24, one with a negative 24. Solve each of those by adding 6 and dividing by 5. And you should get x equals 6 on the left side, and then x equals negative 18/5 on the right. And again, if we were in class or from home even, you're going to want to plug both of these in and check and make sure you get both solutions to work. And I will tell you now, 6 will work, and so will negative 18/5. So both of these are your solutions. Okay, same thing here. We're going to isolate the absolute value bars by dividing by 4, and then we're going to go ahead and drop those absolute value bars to create our two equations, and then we're going to solve each of those by subtracting 5, and we end up with 0 and negative 10. If you plug in 0, it's a really easy check. You're going to end up with 20. If you plug in negative 10, you're going to end up with 20 as well, so both solutions work for this problem. Okay, so for this example, it's a little different than the other ones we had. So we're going to isolate the absolute value bars, which is already done for us. So you don't have to do that. So from here, you're going to just write your two equations. So your first equation is pretty easy. Just drop the bars. The second equation, because you have two different terms on the right-hand side, when you rewrite that, both of those are going to get the negative. And sorry, Ellie wanted to be a star in this video. So from there, you're going to go ahead and solve for x on both of the equations you've created. On the left side, you should end up getting x equals negative 5. And on the right side, we should end up getting x equals negative 5 as well. So occasionally you may get this where you get the same solution for both, so that just means you have one solution, but you still want to check that. And if you plug negative 5 in, you will end up getting both sides equal 0, which makes a true statement, so you're good to go. Okay, same thing here. The absolute value bars are already isolated, so we're going to go ahead and drop those and create our two equations. And then we're going to go ahead and solve each of these equations. On the left, we should end up getting x equals 6. On the right-hand side, we should end up getting x equals negative 2. So we're going to go ahead and do our check. So if you plug in 6, you end up with 2 times 6 plus 12 on the left, which is 24. And then on the right, 4 times 6 is 24. When you plug in negative 2 on the left in your absolute value bars, you're going to have negative 4 plus 12, which is 8. So that would be the absolute value of 8, which is 8. And on the right-hand side, you're going to have 4 times negative 2, which is negative 8. So what ends up happening is when we check our negative 2, it does not work. And that's actually called an extraneous solution, meaning that that solution itself is not one of them. Even though when we solved this, it worked to give you x, but when you plug it back in, it does not work. So you actually just get rid of that answer for that. That's why it's really important that you check these. Okay, this is all just review of what we did on our first day of class when we talked about compound inequalities. You don't need to write this down again since you should already have notes on this, but this is going to be involved when we look at our absolute value inequalities. So if you wanted to just browse through this and kind of remind yourself of how it works and then move ahead whenever you're ready, you can look at the next slide as well. Again, this was just review of your or statements and how they look on a graph and what it really means. Okay, so now you're going to want to write down the steps for solving an absolute value inequality. It's kind of similar to an equation, just the inequality part's a little different. So step 1 is the same, where you're going to isolate the absolute value bars. Step 2 is where it's going to be a little weird. You're going to rewrite the inequality as a conjunction or a disjunction, so as an and or an or statement. And the way you're going to know how, if it's an and or an or statement, is based off of the direction of the initial or the inequality symbol once you isolate the absolute value bars. So if you have a less than or equal to sign, then you're working with a conjunction or an and statement. And an easy way to remember that is less than, and it kind of sounds like less than if you add a D to it. And there you goes for that. Now, if you have a greater than or equal to, you're working with a disjunction or an or statement. So greater actually has almost the word or in it, so that's a way you can remember less than and greater. And then step 3, you're going to do pretty much the same as an equation. In the second inequality, you're going to negate the right-hand side and reverse the direction of the inequality sign. So with equations, we made the right-hand side or changed the sign on the right. We're still going to change the sign, but then we're also going to flip the direction of the inequality sign when we write our two inequalities. And then step 4, we're going to go ahead and solve it and graph it on a number line. Okay, so if you just want to watch this one to see how they work, then you can write the next few down. So first of all, we want to isolate the absolute value bars, but it's already done. So now we're going to go ahead and split this into two different statements. Because there's a greater than sign, this would be an or statement. So we're going to go ahead and get rid of the absolute value bars and rewrite it. And basically, with your rewrite, you can see that this is not changed yet. So what we want to do whenever we rewrite the second one is we're going to flip the inequality sign, and we're going to negate the right-hand side. So we're going to change it to less than and then change it to a -7. Now we're going to go ahead and solve both of those for x. We should get x is greater than 3 or x is less than -4. So because this is an or statement, it's just any solutions that you have on a number line. It would be anything to the left of -4 or to the right of +3. And as a solution set, that would look like what you see here. So anything less than -4 or greater than 3, and then negative infinity to -4 union with +3 to infinity. Okay, this one's a less than statement. Absolute value bars are already isolated, so this is going to end up being an and statement. So go ahead and drop the absolute value bars and rewrite. Again, this one's not true until you flip the sign and negate the right-hand side. And then we're going to go ahead through and solve this one. So we should end up getting on the left, x is less than 8, and on the right-hand side, x is greater than 2. So anything between 2 and 8 would be a solution. If we were to graph it on a number line, we're looking for where this would overlap, so it's only going to be between 2 and 8. And then as a solution set, we would have x is greater than 2 and less than 8, or 2, 8 with parentheses, since it's not included at 2 and 8 as solutions. Okay, let's look at a couple of other examples that you guys can put in your notes. If you guys want, you can pause the video and try this one on your own first, and then press play when you want to check it. But again, isolate the absolute value bars is done, so we're going to rewrite. And when we rewrite the second one, we're going to flip to greater than and then a -2. And because this was a less than initially, it's an and statement, and we're going to go ahead and solve by subtracting 7 and dividing by 2 on both sides. So on the left, we end up getting x is less than -2.5, and on the right, x is greater than -4.5. So if we're going to graph that on a number line, we're going to end up getting anything between -4.5 and -2.5, which is where the overlap would be, and open circles both, and then your solution set would look like this. Okay, so let's look at example 2. So the absolute value bars are already isolated, so we're going to go ahead and rewrite this. And it's less than initially, so it's going to end up being an and statement. So what you're going to end up having are the two statements that you see where the arrows are. But there is a lazy mathematician way to rewrite this instead of into two separate inequalities. What you can do is, because you're ending up changing the sign to a -7 and flipping, this really means you can rewrite the statement as what you see right here. So -x plus 2 is greater than -7 matches what we have on the right hand side, and then -x plus 2 is less than 7 was that initial statement that you see over here on the left. And if you set it up this way, it's kind of set up to already get your solution set by solving for x at the same time on both sides of this inequality. So we know that both of those are going to have to get rid of the plus 2 by subtracting 2, so we do that to all parts. And then you're going to have to drop or get rid of that negative, so divide everything by a negative. And because this is an inequality, dividing by a negative is going to flip these inequality symbols. And what we're going to end up creating is the inequality statement that x is greater than -5 and x is less than +9. So you would get that regardless if you solved it from breaking this into two separate inequalities, or if you like the way this works out, you can try this as well in the future. On a number line, the overlapping between -5 and 9, and then as a solution set, it should be parentheses -5, 9 for your set notation. Okay, so your third example, we need to isolate that absolute value bar first, so we're going to divide both sides by 2, and we're going to end up with this statement here. Okay, so from here we have a less than, so it's an and statement, so we're going to go ahead and rewrite our two inequalities. And we end up solving each of these. So you're going to subtract 1 and divide by the -3. And then keep in mind, when you're dividing by the -3, your inequality is going to end up flipping because you're dividing both sides of that. And then on the right hand side, same thing, you're going to end up flipping. So it looks like our answers here would be less than -4/3 and greater than 2. So if we were to think about this as an and statement, you have to be bigger than 2 and at the same time be less than -4/3. It's not possible. If you were to shade this on a number line, there's going to be no overlapping, so this one would be no solution. This example is a really good look at one that people tend to make a mistake on because they want to subtract the 2 minus 6 while they're solving this, but you don't do that because we're going to have to isolate the absolute value bar. So it's like solving an equation, which means we have to get rid of 2 and get rid of -6 separately. So we're going to actually subtract 2 first from both sides, which would make this, and now you're going to divide by -6, and because you're dividing both sides by a negative, we're going to actually flip the inequality sign right now as well. So keep that in mind. Anytime both sides are getting divided or multiplied by a negative, you flip. From here, we're going to go ahead and write our two statements, and from this point, we've created a greater so this would end up being an or statement. So here's your two inequalities. We're going to add 8 and divide by 2 for each of these, and on the left, we would end up with x is greater than 3, and on the right, we end up with x is less than 5. So as an or statement, if we write this out as a solution set, anything bigger than 3 and anything less than 5 is actually going to eventually cover every single thing on your number line, so this would be in all reals. Okay, go ahead and try this one on your own and then press play whenever you want to check over what the answer should be. Okay, so when you isolated the absolute value, you should have multiplied by 3 and then divided by -4, or you could have done the reciprocal and multiplied by -3/4, and you would have flipped your inequality sign because of that negative. And then we've created a less than, so it becomes an and statement, and then you're just going to add 7 to both sides, and what you should end up getting is x is less than or equal to 10, and at the same time it has to be greater than or equal to 4. So that is okay for an and statement to have that. You can be bigger than 4 and less than 10 at the same time. Your overlapping would occur in between those, so our solution would be anything between 4 and 10, including both 4 and 10. Okay, the last one I just want to show you guys is a word problem, and you don't have to write the words down in your notes. You can just kind of pay attention to how this works. This one actually is very common sense, so you're more likely going to have to just be able to pick out what this absolute value inequality would look like, and it's not going to give you the setup that I have here. So it's basically saying that the manufacturer has a tolerance of 0.75 ounces, meaning it could be 0.75 ounce above or below the ideal weight, which they want to be about 20 ounces. So we're going to set this up by understanding that because you can be above or below, that's what makes this into a absolute value. So the actual weight of a box, if we wanted to represent it, we wouldn't know, so that would be our x, minus the ideal weight, which would be 20, is going to give you the tolerance of less than or equal to 0.75. So then if we would follow through and solve this the way you solve your absolute value inequalities, we would end up getting, when we solve, that x should be between 19.25 and 20.75 ounces for this to fall within the limits that the manufacturer wants. So just be aware of how you could identify absolute value inequality word problems and write them out. And that is it, so I will see y'all soon.